Thank you for being a part of our 10th virtual event organized by Human Who Test. So I'm Shruti, the chapter leader for Human Who Test Bangalore, and I'll be your host for the day. I work with Trigen. Talking about Human Who Test, it's an initiative to improve the diversity in the testing and the tech work. So it aims in equipping the testers with the power of knowledge. And talking about the Trigent, which organizes the event, Trigent is a 25 years old company that enables the business to embrace their digital future. So it helps the clients to overcome their limits by leveraging the technology. And we are happy to announce that the Trigent has won the Best Agile Project at the prestigious North American Software Testing Awards 2020. And coming to the topic for today, as business embrace the cloud transformation, it's vital for the testing function to keep pace with the evolving environment. So in this webinar today, we'll discuss about the cloud deployment tools, how to evolve the organization and process around it. So it will focus on the improvements, coverage, and enhancements in the legacy work. So we have Arun Narayan Swami, who is a director engineer at Amethyst Labs. Arun has a technology leader with 17 years of software experience. So Arun, he helps in he's specialized in cloud and DevOps. So he helps transform development process and bring in cultural changes of their adoption. He hails from Bangalore and he's alumni of INSEAD School of Business, France. So we welcome you for the event, Arun.
Thank you so much, Shruti. I hope everybody is doing safe and well. It's just crazy times. So thankfully, this is a virtual conference. So let's, if it's over to me, Shruti, I can start. Should I share?
Yes, Arun, without further ado, I will let you, take over. Let me make you as a presenter. So yeah, Arun, the presenter rights are with you now.
Perfect. Okay.
Yes, Arun, we are able to see your screen now.
Okay. 1 second. Yeah, you are able to see my screen, right?
Yes, we are able to.
Okay. Okay, let me minimize everything. Just give me a second. I'm just minimizing all the windows because the meeting invite by the screen.
Yeah, sure, Arun.
Okay. Hello, everyone. Good morning. It's good afternoon, everyone. And I again repeat, I just hope all of you are safe, safe at home. You and your families are doing well. Stay away from others. Keep yourself safe. That's the best I can say. And keep positive energy on. All right. So let me start. Welcome everyone. The topic that I'm going to speak about is cloud deployment models. I'll give you my introduction a little later, and I'll also let you know what the context is. Considering this is more of a forum for the testing evolution, the topic covers more on the aspect of how the various cloud models or the various ways cloud is evolving. And the testing that needs to evolve along with it. It's sort of a theoretical topic, so I'll probably give a longer time at the end to have questions. But from a point of view of the technical topic, it's more on the cloud. I'll demystify a little bit of it so that I'm assuming all of you come with various different skill levels and different experiences. So I'll try to demystify some bit of it. But it's to be fair, it's largely on the testing side and how the testing evolves with cloud. Okay. Firstly, thanks for Trigent and Women Who Test who have brought me here to speak to all of you. It's always a pleasure for me to come and speak to someone. And probably you can take experiences of what we have learned and implemented in your life, in your career, or in the organizations that you belong to. So a quick introduction about me. I'm a director of engineering. I take care of the DevOps platform within Amadeus. I have been involved in a DevOps transformation. I have an experience in developer experience. I've managed Center of Excellence for cloud in the past. So my experience is a little mixed on all of these three. To be fair, to be open, I have never managed a team of testers or QA, etc. in the past. But in most of my career, or major part of my career, I've reported into the head of a QA or a head of a QA practice, because a lot of these cloud transformation, DevOps transformation in the past used to be linked to QA. So I understand from a perspective of what the testing evolution is needed. And obviously, while in my current role, we build platforms for internal consumption, and that's important for it to be stable and sustainable. And that's where the testers come in and help in that journey, right? So that's a little bit about me. I want to give you a context of Amadeus more from a point of view of why testing is important. We are a product company. We do not sell anything to customers directly. We are purely in the travel domain. So if you have taken any flights ever in your life, the flights will take off only because of the products that we supply to the airlines, to the travel industry, etc. Right? But what it also means is you've seen how important or critical airline travel is, right? I mean, you're traveling because you want to meet your relatives, your friends, you want to have a vacation, or you're going there for an emergency. All these things mean the airline business or the airline backend needs to be strong, and it needs to be foolproof, right? The concepts of zero downtime releases. I'll give you an example. Let's say if Amazon website is down, yes, it's a huge impact, but it's not really an impact from a point of view of personal emotions to a certain extent. You may not be able to shop immediately, but it's okay, right? Or you will get a delivery 5 minutes late. It's probably okay. I mean, I'm downplaying it a little, but from a context of an airline, if one aeroplane gets delayed in terms of their baggage handling, etc., it has a cascading effect. So from a context, what I wanted to share is the organization that I work for very heavily focuses on testing. And what it means is the products need to be stable for a good customer experience. It's true in various different organizations, but the size and scale of it is fairly large. And that's the context with which I want to progress into my next slide, which is getting deeper into what I intend to share, right? So let's set the context for testing. If I give an example, why testing is important, right? Let's take an example of Ariane 5 flight. This was, I think, in the late 80s or 70s, probably. This was a satellite which was sent to deploy, but it failed, not because of a mechanical failure, but there was a software bug which could have easily been identified, but it was an oversight from the testing side because they did not probably invest well on their testing aspects, and there was a failure. If you equate it to today's terms, it's about $8 billion in loss, which one software bug cost, right? Similarly, it's not just always money. Sometimes the softwares could have a much bigger or a larger impact. There was a Takata airbag. Takata supplies airbags to multiple different car manufacturers. And again, this was not a mechanical failure. It was a bug in the software where the airbag would either come out even when it was not required, or it would not get deployed even when there was an accident, right? So the recall of this airbag system was a $24 billion loss, but more importantly, there were quite a few lives lost because of this airbag software bug not really acting the way it was supposed to act, right? Again, when we look at cloud, what is more important? Cloud is something that's dramatically increasing in terms of usage. We are seeing a major increase in cloud adoption, but there are various studies. I mean, I've seen a Gartner study which says for every 100 rupees used on cloud, 10 rupees is wasted, either through misuse of the resources, either through capacity badly provisioned, scaling not properly done, etc. Right? So those are different aspects of cloud which you will notice that there could be a cloud wastage. And just because of the sheer scale of cloud, the overall, this is already a year old. I mean, people are AWS, Google, etc. is showcasing 50% increase in their revenues. So probably this 25 billion is now close to, when I say 25 billion, this is the loss amounting to the cloud wastage. The overall spend on cloud is somewhere between 250 to 60 million a year ago. So 10% of it translates to about $25 billion in loss, right? So this is purely on the cloud side. But if you look at the cost of software bugs, the combination of software bugs, this was from the Test Alliance report, which I noticed, over the last few decades of software being produced, there was $1.1 trillion lost because of software bugs, right? So if you equate $1.1 trillion on probably a data center, now you amplify that again by another 10% because you're also using, you're wasting money on cloud. So the amount of loss the software industry is basically consuming because of both cloud and software bugs is multiples of these figures, right? So while I put this as a sort of a context in which we should operate, testing is super important. It's evolving dramatically with cloud. You will see a lot of changes that I will showcase to you what is happening with cloud. And it's really important to understand that this function continues to be important and it's of huge value because the cost impact of this in the software development lifecycle is humongous. Okay. Sort of going further, Shruti, I mean, just over to you. Can people ask questions in between, or can they put it on a chat somewhere?
Arun, we can pick up the questions at the last, Arun, like, you know, we should have 10 minutes of questionnaires at the last. So yeah, attendees has a question section where, you know, they can pose the questions and I'll coordinate it to you at the last.
Perfect. Okay. So while I speak, folks, do not wait till the end to type down your message. I think you might forget the flow. So please send out the questions on the chat and we will pick it up at the end. And there are quite a few slides for me to cover and there is a lot of content for you to see. Okay, so when you look at cloud, I mean, this is sort of the demystifying. The way I would split it is I will talk about what's cloud. I will talk about what are sort of the different pillars which are getting affected because of cloud and how can a tester or a QA or a QE engineer evolving in this journey. So I'll sort of, that will be the flow. And when I talk about cloud computing, there are two different models when you look at cloud. I'm assuming most of you understand what's public cloud and what's private cloud. Most of the data centers in the past was like a data center which was fixed capacity. People put on OpenStack, made it sort of a private cloud where you could scale up and scale down within the limits of the data center. And that is where the private cloud infrastructure came in. Public cloud is your Azure, AWS, and GCP. Hybrid cloud is a combination of using public cloud and using your private cloud so that you can get best of both these worlds. These cause a lot of new problems. It has a cost impact, but it gives you a lot of benefit as well, right? On the services model, obviously this is something that you would have seen. Cloud could be used in three different sort of flavors. One is infrastructure as a service. most of the cloud providers initially started off infrastructure as a service, where they would say, okay, this is your compute, this is your storage, put whatever on it, and you could run your application, right? This it's almost like shifting all the content of your data center onto the cloud, onto the public cloud, and say, yes, I'm on public cloud now. The infrastructure which is underneath is that something that I'm using from a public cloud provider, but everything that's sitting on top of it is being managed by me or my company or my team, right? Moving on, a little more complicated process of it on the PaaS structure, which is the platform as a service, which is you use database as a service, right? I mean, you don't install a database on public cloud. Let's say Azure or Google gives a database of themselves, let's say an Azure database or a cloud database, Google database service, and you consume this as a service provided to them. You only store your data, you manage your data on those instances, but let's say the maintenance of the database, patching of that database, ensuring that database is scalable, reliable, stable, etc., is all the responsibility of the cloud service provider. Third one, software as a service, where you delegate the whole process onto cloud. Let's say you consume SAP services to take care of your some product suite or maybe your financial management, etc., and you consume SAP, which is developed onto the cloud, or you use end-to-end analytics service where you just supply data and they just come with end-to-end analysis. That's where it gets to software as a service. Your Outlook, your Office 365, etc., all are software as a services model, right? And why I put all of these, the way you test in public cloud, the way you test in private cloud is dramatically different. The way you test in hybrid cloud is obviously amplified. It's twice the testing you potentially might need. The testers may step up from just doing testing for an application, but also for an infrastructure. And when you look at service models, obviously the delegation in terms of what a team owns and what a team manages versus what a team delegates this activity to somebody externally dramatically changes with IaaS, PaaS, or a SaaS-based model, right? So that's the context with which this presentation is based on. And while I say the cloud evolution is happening, there are multiple things that are changing in the QA evolution or the cloud evolution, where the QAs or a QE needs to get adapted to, right? So these are 9 different sort of the planets around the cloud. I will touch upon each of them, so I'll not go deep into this slide for now, but I'll touch upon each of these while we have this conversation. So what is changing? So there are 9 things that are changing with cloud. The first one, which is the most important one, is the re-architecture of applications, right? Most of our testing methodologies in the past have involved testing large applications, right? I mean, we build huge applications, which I would call monolithic applications. It was end-to-end. When a tester gets into it, the tester is super important. He or she understands the end-to-end workflow of the product. They get deep into the product suite. They understand each and every component of it and test. They do the not just the black box testing. They get into deep of functional requirements and validate it and say, okay, this product is good. But what is the difference between monoliths to microservices? Microservices is multiple small products. The testers get distributed to each of these microservices largely. There is no one central team which is managing QA, and which logically means microservices model causes teams to be fragmented, but they also manage these products end to end. I mean, let's say I can take a microservice of the login module. I mean, earlier, let's say you manage a travel product. Now you manage the login part of the travel, login part of something else, login part of 3 tools is what you manage. The second product, the second microservice could be just a shopping cart, and only the shopping cart is something that you manage. The third one could be analytics part, which is also managed by an independent team. So it could be 3 Scrum teams delivering 3 different microservices, all three are interconnected through APIs. All three are deployed in containers, so they are very small components. And each of them interact through contracts which they need to talk with each other, right? So it's very important to understand that the testing methodology has completely changed. When there was a big application, you're probably deploying once every 6 months or once every 3 months. You have a long lead time for testing, but it's changing in a microservices model where you probably deploy each microservice 100 times a day, and you're quickly churning out test cycles, probably sort of shifting left in the cycle. I talk about it in the slides in the few which come next. Is the bit of how you are evolving to test between small applications, but which was completely contained end to end, but to a microservices model where you have to technically upskill potentially both on the APIs. How do you test APIs? How do you test containers? And how do you test something that's purely contract based and not basically a business functionality flow, right? So that's one thing that's dramatically changing in this evolution. Moving on to the second part, the security, compliance, and privacy. This is the bit that I sort of mentioned on hybrid cloud. When you are looking at multi-cloud and hybrid cloud, earlier you would test, I'm touching various aspects of testing. I'm not just touching aspect of a functional test, but let's look at a security and compliance test. Earlier you would test an application and say, oh, this data set or this business functionality works from a data and compliance standpoint. It's GDPR compliant, or is it compliance from all the requirements that we have in terms of the product, right? But when you look into hybrid cloud, the whole application could be deployed in a third-party organization. The security compliance goes completely different. Let's say if you're, this is a strange example. Let's say a US-based application has to be deployed onto a Germany website or a German data center, right? But the US companies would say, all my data should always be stored within US data centers only. And the Germany would say German data should be there only in the German data centers. So how do you test some of these aspects from a compliance standpoint, right? So these get amplified from a testing viewpoint. And obviously, when I'm saying all this, in a data center, it's a secure environment. You know what you or your organization know, what are the boundaries, how do you control, how do you manage. But when it gets to multiple different cloud providers and you go into a hybrid model, the testers' awareness is extremely important, that you have increased the footprint of your applications to multiple locations, and your performance and security testing is now managed at a much riskier level, and you need to have really good observability dashboards. You need to have good metrics to measure in terms of identifying and coming back to the development teams to say, yes, I found a bug, I found a loophole in the system which needs to be tested, right? One thing for all of you to note, these testers or the QE or quality engineer that we call these days, the scope of activity what was supposed to be done in the past is completely changing in the cloud environment. They're expected to understand cloud deeper in terms of not business functionality, but from a security, compliance, privacy, infrastructure, automation, and all of these aspects, which is where it's important. And again, as a QE or a QA person, you need to look at building action-oriented dashboards, which you can really have quick actions to say, I tested this. And it's not about manually testing, but you need to contribute into building dashboards and building components, which will help testing or the quality function of the product very well. So I'm getting into quite complicated aspects of the cloud, but I think it's more of a mindset of a tester. So I'm basically challenging the QA function on a pure play performance or a functional testing, but to expand the scope to a larger area, because cloud is merging a lot of these functions into one area. So next pillar, which is the scalability, right? I mean, people who are doing performance testing, I think they will relate to it a little better. In a typical, what do I say, in a typical monolithic application, which we were all testing or building in the past, the way an application would be scaled, and what I mean by scaling is, let's take an example of Hotstar, right? Number of people accessing Hotstar website until yesterday or until 2 days back, because there was IPL going on, was about 70 lakh people a day, right? IPL is stopped. Probably the number of people accessing that website is more, maybe only for the OTT platform, probably is 1 lakh a day now, right? So it's 70 times increase, and that 70 times increase and now a 70x decrease or a 99% decrease in the overall workload has to be managed by the infrastructure end, right? In the past, how this would be done is, let's say you have one server, they would probably plug in more RAM and more CPU. That's what we call it vertical scaling. But in the cloud model, it becomes more of a horizontal scaling. Let's say you're implementing your application on one server now, which was one server was good enough to cater to watching Mirzapur on Hotstar. But when IPL kicked in, there were 70 lakh people, so it was a 70x growth. So they had to bring in multiple such instances, and that was helped through the cloud adoption, and there was a 70x increase. And the day IPL is suspended, you need to bring it back to one lakh consumer or one server instance so that you reduce cost, right? So this is managed in cloud in a very different way, and this is where the performance test matters, right? So how would you do performance tests in the past? You would keep a performance test environment which was probably close to production. You would pump in users, fake the users to say, okay, what happens to this when things go up? But on the cloud side, it's probably not required because there is no breakpoint testing. The cloud can continue to scale almost to infinity. It's not really true, but let's take an example. For your application, it could probably extend to an infinite level. A cloud provider could continue to add hardware, and instead of one server, they could continue to provide you 100,000 servers, and you could continue to scale, right? So there is no breakpoint testing. But from a testing aspect, how do you evaluate this and put in calculations of scaling models to ensure that you do performance tests, but not by breaking the system, right? And also, performance test in the past was never a function of cost, because let's say if your performance test, you had a performance test environment, you could go test it there, and even if the test failed and say the performance is not up to the mark, you would go back and say no cost really incurred. But let's say if you want to do the same performance test of 100x the capacity on cloud, you would pay for 100x the capacity for, let's say, the duration you're using it on cloud. So the tester also needs to understand financial models and not really say, I will adopt the same principles of what I would do in a legacy model onto the cloud, right? Then again, I did mention about SaaS service. Earlier, every product was deployed on-prem, so you would have to test everything end to end. But now, let's say if your products, what you build, interact with, let's say, Office 365. How do you test? Because half of the components is completely owned by you. Half of it is provided as a service by a cloud service provider. How do you manage these testing and the workflows across two different things? It's sort of similar to the integration tests, etc., that you would do in the past, but it changes because you might have some things which is on-prem, some things which is a SaaS provider which is on the cloud. How do you test and how do you create a flow between these two, right? So that's very important in that workflow. And again, I touched upon the breakpoint test. Does it really matter? Because you may not be able to do a breakpoint test on cloud because it will continue to scale, and your applications need to be developed in a fashion where they scale. So this again goes back to the bit of containerization, microservices, etc., on how these are built, right? Again, what I'm advocating is the testing evolution. It doesn't mean you have to go to a microservices model. You have to use a horizontal scaling model only. There are use cases for vertical scaling even on cloud. There are non-containerized application workloads even on cloud, but I'm just giving you a perspective of what the major industry moves are towards. Moving on, I think this is the sort of the fourth pillar on reliability and stability. It's the testing. I gave you an example of my own organization where stability is very important, right? In the new case scenarios as well, let's say a pharma industry, stability and reliability is super important, because let's say if you go by the logic of Amazon says we deploy 100,000 times our application onto cloud. I would be worried if Boeing comes and tells me while you're in the air, the aeroplane software gets upgraded 5 times, irrespective of how good their testing process is. I wouldn't trust a new deployment on my plane while the plane is in flight, right? So there are different scenarios for different organizations, but assume, let's say, reliability and stability is important. And for what is very important on the cloud is and which is what is the core aspect of reliability. There are aspects, I think the chart on the bottom right is something that gives you a view. Testing, you test things that you know, you test things that you don't know, and you find problems. And then there are things that you don't know, but because you test, you get to know there are problems. And the last bit, which is the most critical, there are unknowns. You don't know how to test, and you don't know what problems can happen, and you only could probably know about it when it actually goes live on production, right? So these are unknowns, right? And some of these are validated as testing through chaos testing. This comes a little bit more on the infrastructure testing standpoint. I'll give you a very wild example of Netflix. Netflix in early 2000, when they moved from the typical old model of CDs to a digital OTT platform, they deployed their whole platform onto cloud. And what they realized is, as soon as they deployed, I think this was just a few months into production, AWS went down. And because AWS went down, the whole of Netflix went down, right? So they said, okay, we need to do something. They distributed this from AWS alone. They went into multi-region. They distributed that workload. Say if AWS goes down, it shouldn't cause an impact to Netflix. They evolved onto this journey, right? But what really happened, unfortunately for Netflix, AWS again went down, but a different problem I think in about 6 months time from when they implemented this. And Netflix again went down because of this. They realized that there were things that they were planning for things which they knew that is going to fail, but it was something else that was failing beyond what they could do. So they extended to something called chaos testing, where they started introducing failures within their organization by automated scripting, where it would go randomly shut down a server, randomly shut down a database connection, randomly stop the API service, etc. And they started evaluating as an organization to see how a random failure and how my application could sustain random failures, right? So that's the part of chaos testing. I think that's something most of the testers need to understand. This is evolving rapidly. A lot of people are using it. And this is something that's important to understand from a reliability and scaling standpoint. And when we look at hybrid cloud, obviously what happens if one cloud provider goes down? What if both goes down? How do you test the scenarios? And in the world of high availability and looking at disaster recovery, how do you test a disaster recovery site? How do you ensure high availability? Would it be active, passive, etc.? These are all terminologies and understanding that a tester needs to know, so that they are able to build in stronger, reliable products for the future. Sorry, give me a second. Let me grab a glass of water. Okay, so moving on, this was the economic value, which I touched upon a little. The tester is typically the face of a customer, right? So the tester needs to ensure whatever gets handed out from a dev team to the customer is validated, they step in, they empathize from a point of view, or they look from the eyes of a customer and build something as a model, right? Which could be given to the customer. But it also means they have to look at anything that's tested crazy. Obviously means the increase in testing obviously increases cost, right? Great quality, great product, great amount of testing always comes at a cost, right? So the tester needs to also have this from a insight. There are two strategies which are typically common in the industry. The shift, this is not purely related to economic value, but more from the design structure of testing. Shift left is something that we typically do by doing test-driven development. The testers get involved during the dev life cycle, early part of the life cycle. It's not like everything is built, you test. That's sort of shift left. Shift right is you test things in production. You say, okay, I take a risk. I push this to production, and when I push it to production, there are over a period of time, it anyway gets tested, but I have right observability models to check how this is validated. And the tester needs to be a face of both of these. And while I say this, I did touch upon multi-cloud certainly increases cost, increased scope of automation, increased cost, faster iteration of test cycles, increase cost. Instead of you doing one functional test cycle in every 3 months, if you have to do it every 3 days, obviously that increases cost. So the tester needs to be aware of where to implement, what are the priority of testing that needs to be done, how do you classify test cases, and bring in this model for the cloud. This is sort of more of a mindset change. There is a change in org structure which is happening dramatically, people adopting cloud. The QA as a large function is almost getting diluted. They are saying, okay, there is one pizza team. What I mean by a pizza team is any small team that can be fed by 1 or 2 pizzas, right? I mean, which is typically 6, 7 people. These are micro product teams. They build a product, they manage it end to end, and QA gets embedded into that team. So it's not like a central large team like a QA manager, head of QA, etc. Most of these are getting challenged very heavily. So a person will become more of a QE, where the person is becoming an engineer, building automation script much early in the cycle, contributing to the performance testing strategies, contributing to the strategy of understanding how things could get impacted in the cloud. And as I say, there are more virtual teams getting created. QA teams collaborate with each other more on a virtual standpoint and not rather reporting into a head of QA, etc. This is something that you need to be aware of, and mindset prepare, saying an evolution of a QA could be very different from what it could be in the past. Okay. Changes in the deployment strategies. This is how code gets deployed and how coding deployment changes a QE model, right? These are industry terms of recreating, ramping up, blue-green canary. I'm assuming most of you are aware of it. So recreating is basically, when I call it a deployment model, this is not a cloud deployment model. This is the application deployment model. So earlier, a monolithic application, you would bring down a data center. You would say, okay, I have a 2 days of downtime. You deploy the new code, you test it in production and say, okay, open it up for the customer to say, you can consume it now because my product is now, the new version of the product is ready, right? Similarly, recreate is something like that on the cloud. A V1 is terminated, which is the version 1 of the product is terminated. You take a downtime, you deploy a V2, then you open it up. This is typically the legacy model of bringing down an old instance and bringing up a new instance of your application. Ramped up is the way, and your QA model doesn't really change with this. So in the ramped up model, the V2 slowly replaces a V1, in the sense a version 1 continues to exist. Version 2 slowly is brought up in 1 server, 2 servers, 3 servers, 4 servers, etc. And slowly the version 1, which was in 100 different servers, reduces. The QE, obviously, this was also a little bit of an old model. The QA or an SRE needs to evolve on how do you test, when do you take a call of saying, okay, it's not working out, we stop, how do we roll back, etc. And the rollback also needs to be tested, because let's say if you have deployed on 50% of the servers, now you are 50-50 on old and new. Do you take a call to go further, make it 100%, or roll it back because you're seeing multiple issues? The QA plays a huge role in this initiative. Blue-green deployments is you deploy V2 along with V1. So version 2 deployed with version 1. You divert a little bit of traffic to V2, and there is a switch which happens. It's sort of a blue-green switch, and the tester will go, which is the final, the go no-go decision kind of a testing which somebody does. They would say, okay, it's a go on a V2, and slowly the traffic is completely diverted to a V1. The canary deployment model is one of the biggest things that's used in the cloud environment. Is you deploy a V2, only some set of users, and this is something that we keep seeing if people are using Microsoft Teams, people are using, let's say, WhatsApp on the web. You notice that there are some features which are only available for certain set of people. This subset could be defined by the geographic location. It could be defined based on the age group of people, depending on what your application is, right? And the testing really plays a huge role, because you have deployed, let's say you have deployed it to all people on Netflix who only, or logically it's been launched to all kids, right? Any login which happens by a Netflix user who is less than 18 years old gets to use the new functionality. This could be primarily because it could be primarily because the impact what the kids would probably see if the application goes down is not really big, but the tester who is monitoring behind the scenes to say yes, it can now be rolled out from an 18-year-old to a 45-year-old or a 50-year-old, or whatever be the strategy, right? That is something a tester evaluates and not an application person. So this deployment strategy, especially in cloud, and again, Canary, Blue Green have different models in the cloud. It's something that you need to read through, and all these models cause different impact to the testing strategy. Okay, one last bit. I think the rapid evolution and demanding customer. I did mention the QE or the QA engineer is the face of the customer within the organization. He or she should behave like a customer within the setup, step in as a customer, evaluate, and give the product to the customer in a fashion which is usable from a UI based, functionality based, and a performance based, right? So what this also means, in the cloud environment, the response time is very highly demanding. The customers would say, I need new functionality rolling up every 2 days. And when I say a customer, it could be an internal or an external customer. And the QA person needs to be the face of it and develop all the test strategies according to the rapid evolution and change their mindset from the old ways of thinking to a design thinking model. How do you step in the customer's shoes while you are testing? So it's not purely a functional skill. It is also about empathy and the design skills that are required for the QA in the future. Last but not the least, I won't go into details of this because this is something that you all know. There is a huge flood of tools ecosystem. The testers, be it for build, deploy, test, validate, any of these tools are changing rapidly. I'm sure in the last 1 hour of this conversation, there is a new tool that has come up. We've seen Cucumber to Tycho and 100 different tools in the test ecosystem as well. It's important that not to bank on the tools that are used within the organization. The QA person should also look at what is evolving in the industry in the open. And there are a lot of SaaS-based tools which are very easy to adopt. Step in and understand, because that's very important for you to learn. Okay, Last but not the least, I think the Capex to Opex model, it's more of an understanding required for you to know. Earlier, when you had a data center, it was a large Capex model. What I mean by Capex is once you procure the servers, it's all yours. You're not spending money on a regular basis, and your non-functional testing has to cater to a transitioning environment, right? In the Opex model, when you're testing, quite possible that you have a test environment which will only last for 1 hour. As soon as you test, the environment is brought down and it vanishes along with the data and all the test cases that you have done. How do you manage these transitioning environments? How do you capture the data? How do you say how you don't come back and say, oh, when I tested it in last instance, it worked, now it's not working? How do you manage some of these? And obviously, while you're doing, there's a lot of automation scripts, automated test data, AI scripts that are generating data. Testing is evolving from not purely a science, but it's also becoming an art, where you have to understand the financial models, the business models, customer empathy models, and purely the business functionality which you test. So I'll give you a simple case study which we did. Is basically, I'll quickly run through so that you have time for asking questions. Is on the bit of we did one product which we had internally. We migrated to the new model. What we logically did from a QA angle, we transitioned all quality analysts, QA, which we call, to a QE, which is the quality engineer. The quality engineer was also trained on infrastructure testing, performance testing, etc. So instead of a person who was doing maybe a white box testing or a black box testing in the past, expanded their role into doing a lot more of the QE function of writing automation scripts. Python scripts are generating data, helping ensure they're doing the engineering part and not just the QA part. Shifting left, obviously, we moved a lot of these to the TDD, BDD driven models, and most of these became agile teams. So we broke the large QA function to say, okay, the QA becomes part of engineering and we develop part of the engineering, right? And obviously, I touched upon aspects of design thinking and chaos testing. It's something that you can learn from this, saying how do you evolve from one way of working to a new way of working. Last but not the least on this, we started developing cloud native designs, which is important because the tester is involved from day one in terms of all the aspects that I mentioned in this slide. The tester would give their ideas and thoughts in terms of saying how they will manage scaling, how they will manage tests on hybrid cloud, how they will manage security, etc. And this was built into the design of the application. And from I'll touch upon this training bit again in the next one. For a QA engineer, before I summarize, it's important that business knowledge is still the key. What you did in the past continues to be important, but you also need to understand some of the operational processes, which is evolving from being reactive in the past because you were on a waterfall model doing things in the end. You have to be a little bit more proactive and preventive. Training, which I sort of mentioned earlier, it's a ball game of learning, relearning, forgetting things of the past, and upskilling very, very quickly on new tools, technologies, processes, culture, etc. And when you do, it's to adopt to the new culture. The growth path of, let's say, a QA to a QA manager to a senior QA manager to a head of QA may not exist. It could be in a different way. The whole function as QA, I did mention in the first slide why QA is important, but the way it's evolving is different. So most of you will have to evolve from that viewpoint, right? And obviously, all these is helping in lesser employee burnout. It's also helping align in the safe QA methodology. So please be aware things are changing culturally and skill-wise, and you just need to be ready for it. So as the first slide started, testing certainly never stops. It's just changing the way it's being tested. Happy to take any questions on any of the topics that we have talked about so far. Hopefully this was useful and you could take back the learning in your career and in the organizational transformation that you might be going through. Thank you so much. Back to you, Shruti.
Yeah, I'll throw the session open for the audience for their questions. Audience, you can use the tool to post your questions. You have a question option available in your window, so you can use that for posting your questions.
We have about 25 people on the call. I'm surprised nobody has questions. Shruti, can they speak or are they all on mute? Can they speak or is only option?
They would be on mute. The only option available for them would be either to chat or to send out their questions.
Okay. So let's wait for a minute if people are typing.
Yeah, sure.
I don't see anything coming. Shruti, do you see any questions?
I have a question, Arun. What are the change in the skills which are required for our testers?
I couldn't hear you well, Shruti.
Okay, yeah. What are the change in skills that are required for our testers?
What are the skills required for a tester?
The change in the skills.
Change in the skills. I can't hear you well, strangely. Can you type the question to me? Can you type the question to me, please?
Okay, yeah, sure. What are the change in the skills that would be required for a tester? What was my question, Arun?
Okay, what would be the change in skills? Thanks for this question. On the aspect, I did mention in the slides, there are various ways you need to change the skills, right? I mean, these technical skills is certainly one of the key aspects. These technical skills that I mentioned about understanding of new tools, understanding of cloud, and when we say understanding of cloud, it needs to be all functional aspects, financial aspects, operational aspects, and infrastructural aspects, right? So a tester may not be the only, I mean, the growth of a tester, there could be a junior tester who does only one, but as you keep growing, maybe the person needs to involve more at the beginning of the software development lifecycle, where they share these their insights into what could be an impact to testing when you adopt cloud, right? So you need to have, I repeat again, you need to have a functional understanding, financial understanding, and infrastructural understanding from a viewpoint of testing. And obviously, the skills are both personal mindset to say, okay, the way you evolve as a QA is different. Understanding the view of a customer in a fast-paced environment versus a slow-paced environment. The second, which is important, is the learning the skills and tools that are evolving on a day-to-day basis. You can't say, I know only Selenium. You can't say, I know only one or two testing tools. The testing tools are rapidly evolving in the cloud environment. and understanding of all these tools is important in terms of you learning and adopting these tools very, very quickly. I hope that answers.
Yes, Arun. Yeah, thank you.
Okay. Okay, I see nothing more as questions. I really hope it was useful. Feel free to reach out to me if you have any questions, either through Shruti or through my LinkedIn. Happy to help you on this. And all the very best, and continue to stay safe, please. Take care. Back to you, Shruti.
Yeah, Arun, sorry. Yeah, I have one more question.
Oh, okay, okay. Sure.
Yeah, sorry. There are not only the plethora of tools for like from a testing perspective. However, there are also tools that supports the entire CI/CD pipelines like Docker or the Kubernetes. How much of understanding is required for these tools?
I would probably put it in a very simple way, is for the tester to evolve beyond just saying, I will only find bugs or I will only find a problem in a system, right? I mean, it was not in the negative term, but that was the role of a tester in the past, right? So in that context, the deeper the understanding of technology, of Kubernetes or Docker or Jenkins or any of these in the life cycle of a software development would certainly help in testing the process and testing the product in a better fashion. So there are various fundamental courses that you can take to understand this. I'm not saying you need to be a hardcore developer on Kubernetes or understand deep down Docker, but it is always good to understand at a higher level. And obviously, if you're testing containers in terms of an infrastructure performance standpoint, then you obviously have to know this a little more in detail than just at fundamentals.
Yes, Arun, got that. Yeah. So audience, if in case you have any questions going further, you can drop us an email and we will forward that questions to Arun, and we'll send you a follow-up email for that. So yeah, thank you, Arun. That was a great session. You explained the critical role of a QA in enabling the world to go as an usual. So we had a comprehensive look at the technology evolution. So, and this has helped us to better prepare for the changes ahead. And the way you put the 9 planets of QAs to hop on was innovative, and indeed, testing never stops. So on behalf of Women Who Test, we thank you. It was wonderful session, Arun.
Thank you so much. Pleasure talking to you all. All the very best. See you.
Thank you, audience, for all your time. Thank you, Arun. Bye-bye.
Thank you.